Hello everyone, my name is Dewey Spangler. I am the manager of the Ware lab for the College of Engineering here at Virginia Tech. And what we'd like to do today is discuss the 10 projects that we have housed here in this facility. Joe Ware was the founder of the Ware lab. He is a 1932 alumni of Virginia Tech. Joe wanted the facility that was available to undergraduate students. The teams that you're going to be hearing about today all go to a competition. And to get things started, I'd like to introduce the Baja team.
This is Team Baja. So as you can see, the goal of our project is to build an off-road dune buggy, if you want to think of it that way. And the best part about this project is the students themselves design, construct, build, race, wreck, and fix the car in numerous competitions throughout the year. They design their vehicle, they give a pitch on how they designed it and why they designed it the way they did, as if they were marketing it to a company to manufacture and sell as a product. We're primarily mechanical engineering with others who are kind of working their way up to that level. The more experience, the better when you have on our team. So if you get started early, you can move up and be part of the leadership of our team. This is Team VT Bolt within Mechanical Engineering Department at Virginia Tech. Our primary goal is to take a gas-powered motorcycle, like we see here, and convert it to an electric-driven motorcycle. So our goal over the years has been to take this gas bike, understand the workings of a gas motorcycle, and then convert that to a fully electrically driven motorcycle. We have students from all academic levels. Freshmen, we like to get freshmen in very early and quickly. Sophomores, juniors, and seniors. The seniors on the team are part of the senior design project within mechanical engineering. And those are the students that lead the effort to design next year's version.
As an engineering student here at Virginia Tech, every student participates in senior design. So they're supposed to be designing a product for a customer. Our customer officially is the weekend hobbyist motorist who's going to drive a formula-style race car. We design and build cars to perform and compete during a trial in Michigan at the Michigan Speedway, a race out in California, and this following year we're going to be going to Canada and participating in Formula North. We're primarily mechanical engineers. We do have some aero students that are responsible for designing the aerodynamic components. We also have some industrial design students who are responsible for manufacturing processes, but primarily we are mechanical engineers. We produce more in terms of percentage of the parts on the vehicle. We produce as much, if not more, than any of the competitive teams, probably in the nation.
The human-powered submarine team is basically competing in a biannual competition, so it's every 2 years. The whole goal of the race is for them to basically design, build, and pilot a fully flooded submarine that's powered only by humans. The goal here is it's a drag-style race where they're supposed to go approximately 100 meters. The goal is to go as fast as they can. So due to safety concerns, each team races separately, and they just time all of the races, and then they come up with an overall winner at the end. In terms of majors, there's mostly mechanical engineering majors, ocean engineering majors, and I guess general engineering majors, because there's a large number of freshmen that tend to participate on the team.
This is the Design, Build, Fly team, or commonly known as DBF. What DBF does is design, build, and fly a remote-controlled balsa wood carbon fiber airplane that goes to a competition in Kansas every year. 2 years ago, for example, they had to design an aircraft that consisted of just a wing. About 4 years ago, they designed an airplane, so this airplane is completely hollow. It accommodates the smaller airplane, and both planes have to land, and they had to disassemble the plane, and then the smaller plane had to take off. That simulated a military-style mission where you have airplanes within airplanes. So the DBF team has to change their whole way of thinking every year. This is the Sellby team. Again, ocean engineering students and computer science and computer engineering students work on this program because it's a fully autonomous project. This would have been their 5th iteration, as far as the 5th time that they've gone to competition. Last year they did very well. They got 2nd place out of 24 teams, and we look forward to seeing how they do this upcoming year. On this side of the bay is the astrobotics team, which is a mechanical engineering team. But again, they also recruit from computer science, from computer engineering, from aerospace and ocean engineering. They build a robot that is designed to mine the surface of the moon, Mars, and asteroids. If you can mine materials in space as opposed to taking them from Earth, it represents a huge cost savings in the space mission itself. At this time, I'd like to introduce the Steel Bridge team, which is comprised mainly of civil engineering students, but we also have building construction, architecture students that serve on the project. And the Steel Bridge team constructs a 20-foot span structure that can carry up to 2,500 pounds. So it's a viable, real structure that's a 1/10 scale compared to the actual bridge that you would build in reality. They build a modular design, meaning that everything has to be within a 3-foot length and has to be able to fit inside a box that's used at competition. So the judges will actually check each member of the bridge. If it doesn't pass this test, then the bridge can't compete at competition. Like all teams in the Ware lab, they design on the computer before they order material, before they do any construction or testing. This is how real engineering is done. In addition to the Steel Bridge team, we have another civil engineering project here in the Ware lab. This is the concrete canoe. And again, this team consists of volunteers from civil and environmental engineering, construction, and also architecture. So they make concrete float, and they use a lightweight mix, which has about a unit weight of about 60 pounds a cubic foot. Water has a unit weight of a little over 62 pounds a cubic foot, so this concrete will actually float in water just like ice. So that gives it buoyancy. Also, the canoe is shaped in a hydrodynamic manner to give it additional buoyancy and also speed through the water. And each year, Concrete Canoe has a different theme, and that's part of the fun of the project. You get to present on that theme. So again, just like Steel Bridge, Concrete Canoe will go to a regional event within Virginia, and then if they score well enough, they'll move on to a national event somewhere in the United States. Our final stop on the tour today is the Hybrid Electric Vehicle Team, or HEVT. This team is a project that takes a vehicle that is donated by General Motors and converts it from full gasoline powertrain to hybrid technology. What you see here is the Camaro that was retrofitted by the team 3 years ago and performed very well at competition. And they took the 6-cylinder engine out and replaced it with a 8-cylinder engine. So they actually increased the horsepower of the gas powertrain. And in the back, if we walk this way, the students will construct the 340 volt battery system. It consists of 7 lithium composite batteries in series. This is a 4-year cycle. They start out with design and conception in the first year, and then the next 2 years they prepare the car through the retrofit, and then in the last year they do the final competition out in Arizona. We have been very consistent in our winning. The last 2 years we've earned 2nd place out of those 16 teams. So this would be interesting, I think, to mechanical engineering students and also to electrical, because they have to take an electric powertrain and make it work for the mechanical system. So at Ware Lab, we emphasize safety, and part of being in the lab is getting certified to work in the space, and that involves earning one of these badges. So in order to do that, you have to take 6 online safety classes through Environmental Health and Safety. The white badges are worn by students who have passed their machine shop safety certification. So once you do that and you train with our shop manager, you receive this badge. It's signed by that person, and you wear that badge at all times while you're in the machine shop or the weld shop.
One of the things that the students have to do is go through the ISE 2214 Manufacturing Process Lab to actually get certified to get trained in this machine shop. Now, once they come in here, they've got a 3-hour process they have to go through. It's called an orientation that we actually go through each machine, show the students how to work the machines and so forth. And also after that 3-hour orientation, the students have to actually qualify by making 2 parts. One on the lathe and one on the mills over here. So square part and a round part and so forth. And then once they've done that, they're certified to come in here and actually use the shop.
I would say as an engineering student at Virginia Tech, one of the primary responsibilities you have is to get practical experience. That is probably the #1 thing I hear from companies who come here and want to hire our students. Does your student have any practical experience? There's no better way to get that practical experience at Virginia Tech other than being part of a team in the Ware lab in mechanical engineering.